Okay, I'm back.
Yay, things are fixed.
What are they all showing?
Okay, let me see. It's telling me it's launching. Oh, wait, there.
Yeah.
Cross your fingers.
Okay, share screen. Okay, hopefully the same thing. Okay, how's that? Do you guys see the?
It's loading, or at least on my side it is.
Yeah, it's loading for me.
Loading slowly, really?
Yeah.
Oh, there we
there
go.
Yay.
Just took a minute.
Okay, so what'd you guys get for the molar mass for nitric acid?
63.012.
Oh, one. Yeah.
Let me see. What did I get? Yeah, I got 63. Oops.
No, two.
Draw. 63. Shoot.
Oh no. Oh.
63.02 grams per mole.
Yes.
Yeah.
Okay.
Yeah.
You know what? I don't normally draw that much in Word. Maybe that's my problem. Okay. And how about for copper nitrate?
187.56.
Yep. And then what would you call this? The NO2, what's the name of that?
Nitric acid.
Nitrous oxide.
Nitrogen dioxide.
Oh, what's that? Is that laughing gas?
I believe it is, yeah.
Bill. You know your stuff, Bill.
Important stuff. And water is 18.02 grams per mole. Okay, so
Do
we're
you
gonna.
always want us? Sorry. Do you always want us to go to 2 decimal points like this?
No, 1 decimal point is generally good.
Okay.
Now I don't know why my.
Professor?
Yeah.
What about in lab? That's just depending on context, right?
Yeah. Yeah.
Okay.
Okay, well, I don't know what just happened when I was scrolling. It wouldn't take the words with it. I think next time I'll probably use EndNote or Note, whatever that thing is called, to solve this, to work on the screen. Okay, so question number 2, we have this reaction. It's copper metal reacts with nitric acid to form copper 2 nitrate water and nitrogen dioxide. And what I'm doing is laying out step by step how to do a limiting reagent problem. So the first thing we need to do is figure out how many moles of copper we have. And the reason I did the first part was so that you would have the molar masses already there for you. Okay, now to calculate the moles of copper, we'll start with the number of grams that we have of copper. And then we'll use the molar mass, right? What's the molar mass of copper?
63.546.
Yeah, so let's just say 63.5. That's from the periodic table. So 63.5 grams of copper per 1 mole of copper.
Yes.
And when we multiply that out, it's
2.05.
yeah, so 1.05 moles of copper.
2.05.
2.0, oh yeah, 2, duh. Because there's twice as much grams as there is the number of grams in a mole. So for nitric acid, it's the same process. We're going to figure out how many moles we have of that. So 130 grams of nitric acid. Oh, I wonder if this is recording.
It says it is at the top.
Oh, good. Okay.
Mhm.
Who knows what happened with the other part. Okay, so with nitric acid, we're going to use the molar mass of the nitric acid that we calculated, and that's 63, right?
Right.
0.0 grams. per mole of nitric acid. And that comes out to, what does that come out to?
2.06.
Okay, 2.06 moles of nitric acid. So we actually have more molar quantity of nitric acid than we have of copper. So your first thought might be, well, copper will be my limiting reagent because I have less of it. But if you look at the chemical equation up here, we need, for every 1 mole of copper, how many moles of nitric acid do we need?
4.
4. So that's another way of looking at that, is to say that we would need 4 times the number of moles of nitric acid than copper.
Okay.
Okay, so now we're going to take those mole numbers, which so you want to keep moving with me. So that was 2.05 moles, or what was it, 2.03 of copper?
05, I believe.
2.05.
Okay, oops, of copper. Okay, and so this question is, use the number of moles from part A to help you answer the next question. How many grams of copper nitrate can 130 grams of copper produce? So we know that when we go from one species in a reaction to another, we have to use mole to mole ratios. So we want to start with the moles, and I actually had you calculate that in A. So we don't have to do that again. So we know that this is 2.05 moles, this 130 grams. So how are we going to calculate how much copper nitrate that makes? Well, let's say if I had 2.05 moles of copper, how many moles of copper nitrate will that, how much can that produce? Right, for every 1 mole of copper, I get 1 mole of copper nitrate. Sorry about my writing. So I'm gonna use I'm gonna try to put my thing flat again, and hopefully it won't freeze.
Or are you asking about like stoichiometric ratios right now?
Yeah, exactly. Yeah, I think the challenge in this section is sometimes understanding the language of what I'm asking for. Okay, so it's 1 mole. I get this from the coefficients in the reaction. 1 mole of copper makes 1 mole of copper 2 nitrate.
Right.
And then the question, though, they want to know how many grams. So to go from moles to grams, I'm going to use the molar mass. And we calculated that in the first part. So 1 mole of copper nitrate is how many grams?
63 grams
Mm,
of HNO3.
no, we want copper 2 nitrate.
Oh, copper 2 nitrate.
Right, because this is a mole to mole ratio.
6.
This is a molar mass.
Did we not do that one in the first problem?
Oh, do we not?
First problem, yeah.
It's 187.6.
Yes.
Do you know what I did there to get the 187.6?
Found the molar mass.
Yeah, I added the mass of copper plus 2 nitrogens plus 6 oxygens. Okay, so when we calculate that out, I get 385 grams of copper nitrate. What do you guys get?
I think we're still writing it.
Okay. This is going more smoothly than I thought it would.
Good. I know it's very threatening before you hop on and get it going.
Oh yeah. Well, and there's just so many windows and
Yeah, it's easily you can get lost.
uh-oh. Uh-oh. Shoot. Well, see, I got confident there and I screwed up. Can you guys still see everything okay?
Yeah. Nothing's changed.
Nothing's changed. That's on my end. Okay, so are we caught up to the 385 grams of copper 2 nitrate?
Yes.
Okay. So that is that's the number that if we had an unlimited amount of nitric acid, that's how much copper 2 nitrate would get made. But when we do a limiting reagent problem, we have to calculate the quantity that gets made with both starting reactants. So part C is use the answer from part A to help you answer this question. How many grams of copper 2 nitrate can 130 grams of nitric acid produce? And we calculated that that was 2.06 moles of nitric acid, right? Oops.
Yes.
Okay, and so this question is asking if I had excess copper and I had this amount of nitric acid, how much copper nitrate would I get? So it's going to be the same exact format as up here. So we'll start with the 2.06 moles of HNO3. And what do we do next?
A mole to mole.
Yeah, exactly. Mole to mole ratio. And I see from this coefficient up here that it requires 4 moles of nitric acid to make 1 mole of copper 2 nitrate. And then, let me see if I can change. I'm getting brave now. It sort of worked. So I've canceled, oh, it just went away. I've canceled the moles of nitric acid and now I have moles of copper nitrate. And I'm going to use the molar mass of copper nitrate again to get the grams of copper nitrate. So 1 mole of copper nitrate is 187.6 grams of copper nitrate. And with that one, I get 96.6 grams of copper nitrate.
So that makes copper nitrate our limiting reagent.
Wait, hold on. Sorry.
It's okay.
So our limiting reagent will either be copper or nitric acid, because this is how much we get from the amount of nitric acid we have. This is the amount we get from the copper. This one is less, right? So that means that the nitric acid is our limiting reagent. And maybe that was what you said, but
it just seems so simple for all that work. So I'm like wait.
Well, sometimes the tendency is to go with what gives you more, but you'll run out. If you think of the recipe analogy, you would run out of the copper before, I'm sorry, wait, you would run out of the nitric acid before you would have, what am I trying to say?
You would run out of the nitric acid before you would reach the excess amount of the copper.
Yeah, thank you.
Like they wouldn't equal up. You'd run out.
Yeah. It's
Before the
easier for
chemical
me to
reaction.
think of, it's like I would have more flour than yeast or something. It's
Yeah.
easier to think of it that way.
Like
Okay.
it doesn't balance out.
Yeah, they're not in equal amounts. They're not in the proper ratios for the recipe. Okay. So this is a big part of what we've been doing. So, and there are examples in the homework, and I recommend working examples in the back of the book if this is challenging. The evens are, question?
Yeah, I did mine differently. Got the same answer.
You did?
Yes.
So,
I'm
well,
sure there's more than one way to skin this cat.
yes, there is. And if we were in the classroom, I would just walk over and look at your sheet of paper.
Well, what I did is I used 130 grams of HNO3 and multiplied it times the molar mass of that. Then I got the ratio of the molar ratio, and then I multiplied that times the molar mass of CuO3, and I came up with 96.6.
Yeah, that's exactly what we did. The only difference is that you did the step for this number here.
Okay,
We did it in part A, so we just started with that
I
number.
got you. I understand now. Yes.
Yeah. Well, and yeah, and every semester, I set this up as a way to help people get through it incrementally, but it never fails to confuse people. So I think, and I leave it in there because I want people to understand what they have at each step. And I think, what happens is you get on this, you get a method and you just want to start your method and get to the end. But I want to make sure you understand what each step of the method is getting you, if that makes sense.
That's good,
Okay.
Sam.
Okay, so here's another type of question that we've covered, and these are classifying the reactions in question 3. So we can do a combination, which is a synthesis reaction, where you start with a simple molecule and make something more complex. A decomposition is when you start with a complicated molecule and break it into smaller pieces. And then the single replacement, or it's also called single displacement, and double displacement reactions, or combustion. So you want to be able to look at these reactions and tell me what kind they are. So the first one, that's sodium azide is the name of that compound, and it breaks down into sodium and nitrogen gas. Of those 5 types, what would you call that?
Would that be decomposition?
Or
Yeah.
decomposition.
Yeah, awesome.
Breaks it down.
Yeah. Okay, and then what about the second one?
Combustion.
Yes, so combustion, this is just something you have to remember. Combustion always is a hydrocarbon reacting with oxygen, and the 2 products are always CO2 and H2O. And Bill, remember your question about liquid versus gas?
Yes.
These should both be gases here.
Ooh. Okay.
But I would be okay with the liquid.
Understand.
Okay, how about the third one?
Single replacement.
Single replacement.
Yep, yeah. So this isn't as scary as it sounds, right?
No.
Okay, and then the fourth one?
Double
Double.
replacement.
Yeah, double replacement. Okay, and we're gonna skip this because I don't like they cover that in the chapter. Okay.
So would a combination kind of be like a decomposition, like backwards and reverse?
Yes.
Okay.
Yeah. So any decomposition that you take, if I flipped the products and the reactants on this, that would be a combination. So if I run it in that direction.
Okay. Thank you.
Yeah, and that's always true. And I almost never say always. Okay, so these are more challenging. So it's telling you that you have a single replacement reaction, and it's asking you to predict the product. So that means we're going to have an element and an ionic compound in the products. And here's what I look at. Hydrogen is +1 here. That's the ion it forms. Chloride is -1. Aluminum is 0 because it's in the metal form. But when it makes an ion, what kind of ion does it make?
+3.
+3, right. So what's going to happen is the aluminum in the product is going to pair with the chloride.
Oh, nice. Okay.
And so always do the product formulas first. Uh-oh. So aluminum chloride is going to be AlCl. How many chlorides do I need? 3. Okay. Then hydrogen's going to be by itself. So what would hydrogen's formula be?
H.
Mm-hmm.
H2.
H2. Woo-hoo. Oops, that's a 2. Okay, but now we need to balance it. So I see 3 chlorines here. That means I have to have at least 3 HCl's. But if I do that, then I can't have an even number of hydrogens. So I think this is gonna be 6. And this is gonna be 3, and that should work.
Because again, why did you have the H2 over there?
Because it's one of the second 7 diatomics. Remember they make a 7
Yeah.
on the periodic table, and then hydrogen is the other one.
Yeah, but why did you? Okay, I thought hydrogen would be there by itself. I didn't think it had to have 2 of them there.
No, you do, because it doesn't exist by itself.
Oh, that trick. Okay.
Yeah, yeah. So it would be the same if I said I had chlorine. You'd have to do Cl2.
Okay. So it doesn't H by itself does not exist. So that's why you put H2, correct?
Correct. Yeah.
Okay.
So, Professor, do you need a 2 in front of the ALs to get
Over
6
here?
chlorines?
Do I need where? In the first reaction?
Right.
I don't need a 2 anywhere, I don't think. Because I have
The chloride.
Don't you have 6 chlorides on the left and 3 on the right?
3 chloride on the
yeah,
right.
you're right. Thank you. So yeah, I need 2, and then I need 2. Is that what you're saying?
Yes.
Okay. Oh, and it would help if I looked at my answer key. Okay, thank you for catching that. Okay, so again, the magnesium metal reacts with hydrochloric acid, and this is again a single replacement reaction. And the charge on the magnesium is 0. The hydrogen is +1, the chloride is -1. So the first thing I'm going to do is, and we know that, well, what kind of charge can magnesium make?
+2.
+2. So it's going to replace, in the replacement, it's going to replace the hydrogen.
Oh, nice. Okay.
So first we do the formula. So magnesium with chlorine would be what compound?
Magnesium
Right.
chloride.
MgCl2.
Would be, the name of it is magnesium chloride, and the formula is MgCl2. So the thing that I want to make sure you remember is always figure out the formula for the compound before you even start thinking about balancing the chemical equation. Because sometimes people look at what they have and they try to make compounds that don't work because the charges wouldn't be 0. Okay, so then what's the other product going to be?
H2.
H2.
Yeah. Okay, and then for balancing, I'm looking.
Do HCl.
Yeah,
2 in front of them.
yeah, that's it. Okay, So, and then the next one is it's zinc metal reacting with sulfuric acid. And the zinc is 0 charge here because we know that because it's the metal and it's by itself. What is this? SO4, what is that?
Sulfate.
Sulfate, right? And so that's -2.
Professor,
Yeah?
what about the state? Like you put gas for H2 for all the other ones,
Yeah.
but do you need to know for Al aluminum chloride? Do we have to put the state?
You
Yeah.
know, your homework may want you to have it. My feeling is on a test, if you can get the product, I'm really happy. And the aqueous is you're looking at the solubility rules to determine
Okay.
whether the magnesium chloride would be aqueous or solid. Now the aqueous versus solid winds up being important for the next the double displacement reactions. Okay, so what do you guys think for the products for this reaction here?
Z and SO4.
What is it going to be?
Z and SO4.
Yeah.
H2.
Zinc sulfate.
Yeah. Now why? So zinc sulfate, because zinc can only be +2. I don't know what is going on. Why I'm getting. Do you see the boxes on your screen?
Yeah, it's okay though.
Okay. And -2, sulfate is -2 and it stays -2. And then we have the hydrogen gas left over. Okay, yay.
So that's
So
balanced.
why is zinc always +2?
Your book doesn't say this, but zinc, if you look on the periodic table, you see where zinc is?
Yes.
Okay, there are 3 transition metals that only adopt 1 charge. They're not, they don't have different charges. And the 3 are zinc, which is always +2, cadmium, which is always +2, and silver, which is to the left of it, which is +1. Those 3 are right near each other.
Oh, wow.
Yeah, and so otherwise you would need more information to get the name or the formula for zinc sulfate. If it could be zinc +3, then we'd have to know the more information to figure out what the chemical formula would be.
Question, Professor.
Uh-huh.
If you know SO4 has a -2 charge, can you assume that zinc's going to have a +2 charge?
No, you can only assume zinc's going to be a +2 charge because we know it's zinc.
Ooh, okay.
Like if like for example, if I had copper, I would have to tell you whether it's copper 1 sulfate or copper 2 sulfate.
Right.
Because copper can be multiple. You would need more information to be able to write the product.
Yes.
Okay.
Thank you.
One more thing. Can you
Yeah.
name those elements that it was zinc and what was the other one?
Cadmium, it's CD. It's underneath zinc in the periodic table.
Right.
And then to the left of that is silver, which is Ag.
Which one?
And those take
Oh,
on charge to 2.
Cadmium and zinc are +2, and silver's +1. And the reason for those charges will make more sense when we cover the next chapter.
That's something we should probably just brute force memorize.
Yeah,
Right?
you do. Okay, the last 2 equations. These are double displacement reactions. So we're going to swap positive and negative ions, but I've also added, you're going to have to translate them into formulas first. So potassium, K, right?
Yes.
And phosphate is what?
PO4.
PO4. We have to balance the charges, right? Phosphate is -3 and potassium is what charge?
+1.
Yeah. So how many potassiums do we need?
3.
3.
Okay. And then calcium bromide. What's that?
CaBr2.
Yeah. Okay, so we're going to swap positive and negative ions. And again, write the formula first, then try to balance. So the positive from my first compound will go with the anion of the second. And that is, I have potassium and bromide. How is that formula? Is it okay?
Yes.
Yes.
It is, because calcium's plus, potassium is +1 and bromide is -1. Then I'm going to combine calcium and phosphate. Calcium is +2 and phosphate's 3-.
So
What's this formula?
calcium 3,
Calcium 3.
phosphate 2.
Yeah. So now, once you've determined the correct formulas for the products, then you balance.
Oh.
Okay, so what are we gonna do? I'm seeing a 6 again, probably. Oh, and actually I can look at my answer key. So I get 6 there, 3 and 2. Oops. Oh, and now one last step. For these, it's really crucial is to see whether we have a precipitate, otherwise there's no reaction, right?
Right.
So which one of the products is not soluble?
Phosphate, the calcium phosphate.
Yep, that's our precipitate, and this one's aqueous. Why is it, and how do we know that?
Because of phosphate.
If you flip over your periodic table, you have the solubility rules. If somehow I managed to tape one that doesn't have it. But potassium is always soluble, and phosphate's one of the things that's generally not soluble.
Oh,
On the exam, are you going to want us to write that out too? What the precipitate is?
I think what I'll say is identify the precipitate.
Okay.
Or if there is one. Okay. Okay, rubidium hydroxide. Rubidium's Rb. What charge does rubidium make?
+1.
1.
+1, because it's in the first column, the first group. And hydroxide is OH-. So that's that formula. Magnesium goes to +2, and sulfide is, what's sulfide?
SO3.
That's sulfate. Oh, sulfite with a T.
Sulfide is
SO4 2 minus.
No, that's sulfate.
SO2.
Also, it's just the S.
It's got the D. Remember, if there's a D, it's just the element. It's this.
right.
So,
MGS.
MGS, yeah. When the anion has a D in the name, other than hydroxide, it's always it's not a polyatomic ion. It's just the element by itself. Okay, so we're going to swap anions and cations. So rubidium sulfide. Is that okay?
No.
No.
Two.
RB2.
2.
Yeah, RB2. Okay, then what else?
Magnesium. Oh,
Need 2 hydroxides.
yes.
Yep. Okay, what do we think about solubility?
Sulfate isn't.
The sulfide?
Yeah, sulfide.
I don't have my rules.
Well, 2 minus is generally not soluble.
MgOH is
Yeah.
a solid.
OH is also insoluble.
So I have 2, right?
Yep.
Okay. Okay, well, that was my ambition for today, was to have people with me through this. So, and again, these are really good examples for the free response.
Professor,
Yeah.
does a 2 go over here
Oh,
the
we have to
left
balance.
side of the equation?
Yeah, sorry. I was so relieved to have made it to the end of the problem. There, right?
Right.
Okay. So any other questions? Are you guys feeling maybe a teeny bit less stressed?
Yeah, I'm feeling more confident about it after going over it as a group.
Oh, good, good. Okay, so
Hey, Professor.
yeah,
Quick question.
yeah.
When you're trying to balance the equations, other than just putting in numbers and seeing if it works, is there any other way, any other more sophisticated way of trying to balance the numbers?
Oh, well, when I let's see. So one thing is I always say keep the polyatomic ions together if they're on both sides. But my general method is to list the atoms in order on both sides. So for this example, what I would do is I would say, okay, I have rubidium. Oops, uh-oh. I have one rubidium. I have one hydroxide. I have a magnesium. And I have a sulfur. And then for the products, which I just erased, I would list the atoms in the atoms in the polyatomic ions in the same order.
Okay.
And then let me see, I had rubidium, hydroxide, and MgS. This is not the best example because it's simple, right? Oh wait, no. I just wrote the reactants again. Rubidium sulfide and then magnesium hydroxide.
Right.
Okay.
Oh, yeah.
So so now I have two of those, I have one of those and two of those and one sulfur.
Right.
And so what I do is I would try something and our answer was to put 2 here. And then I update my numbers.
Okay.
That's really, and then I just go, I find it helpful if it's a complicated one to have every piece listed in the same order on the left as you do on the right. And then to update my numbers. Some other suggestions are to always balance something by itself last. Do you guys want to do a combustion reaction?
Yeah.
Yeah.
Okay, let's do a combustion reaction and I'll show you what I mean.
There's one on the homework and I could not for the life of me figure out where I lost that hydrogen to, but it was water.
Were you forgetting to take into account 2 products or something?
Yes.
Yeah. Okay, let's do let's say we have the combustion of propane.
Lily.
Okay, so propane, you wouldn't know this, is C3H8. And I could write this on an exam, actually it would be fair game, is to say, write the balanced chemical equation for the combustion of propane. And that's enough for you to know that the propane reacts with oxygen and it makes CO2 and water.
If you're writing, we can't see what you're writing.
Yeah, I can't see what you're writing, Professor.
Oh, did you lose my screen?
Yeah.
I think
There.
What are you looking at?
it's at the reaction type chart, so like number
Oh.
3 question.
Okay.
There we go.
Thank you.
I thought it was maybe just my computer lagging, but
Okay. So, and I I was just going to cover a paper on my screen, which doesn't do anything for you. So let's say I could start the equation like this and say, write the balanced chemical equation for the combustion of propane. But I'd give you the formula of propane, but then you have to know that a combustion reaction is a hydrocarbon reacting with oxygen And it will always make the products of CO2 and H2O. Okay, so now we need to balance it. And I'm going to write CH and O on either side of the chemical equation. And I'm going to write down the number of each thing that I have. So 3 carbons, 8 hydrogens, and 2 oxygens on this side. And I have 1 carbon here, 2 hydrogens, and how many oxygens on the product side?
3.
3. Okay. So for a combustion reaction, there's 2 things I always do. I always start with balancing carbon. And then I always end with oxygen. The reason I balance oxygen last is because it's by itself. So however many I wind up with on the product side, I can just give it on the reactant side. And it won't change anything else. So what do you guys want to do first? Or what should I do first?
Carbon,
Yeah, and what should I put there?
3 on the reactant side.
On the product
On the
side.
product side.
Yeah, that's okay. So then I'm going to update my numbers. So now I have 3 carbons and I have 6 plus 1 oxygen. So I have 7. So then second, I want to balance my hydrogens.
4 in front of the water.
Yep. And then again, update my numbers. Do you guys see my keyboard popping up?
Yes.
Yeah, I'll have to figure out and use EndNote next time. It's easier. Okay, so now with 4 waters, I have 8 hydrogens, which is good. And I have 4 plus 6 oxygens, 10, right?
Yes.
Yeah.
So then the final thing I do is 5 O2s.
Oh, okay.
And then that's it. Because I have 10 oxygens, and then when that's done, I have 10 oxygens there. So I always start by, listing things, take the most complicated one and try to balance that first, because it would be harder to fix everything later if there are multiple pieces. Right, so this is my most complicated molecule, I think, and so I'll start by trying to balance elements of that.
Okay, thank you.
Yeah, and if you have examples that are tough, you can send me a picture and maybe I can do a video of how I would approach it.
Professor, on these kind of equations, to me, this was pretty straightforward. I get kind of messed up. Say, for example, on the product side, oxygen, you have 10. Say that had been 11. You would have had to put 11 over 2 up there at the top and then multiply the whole thing. That kind of screws me up when that happens.
Okay, well, let's do that. So C4H10. Oops. C4H10, go away. I don't know how to get out of this mode where it wants to start the keyboard. Okay, plus O2 becomes CO2 and H2O. So CHO, CHO, 4, 10, 2, 1, 2, 3. Are you guys caught up?
Yes.
Yes.
Okay, so what should I do first?
Carbon.
And what should I put there?
4.
Okay, so that becomes 4. 8 plus 1 is 9. Okay, then I'm going to do the hydrogens, right? What do I want there?
5.
5. So now I have 10 hydrogens and I have 8 plus 5 oxygens, 13.
Yes.
Okay, so I need 13 oxygens, but oxygens come in units of 2. So that's the problem. And you're not supposed to do that, although there was some example in your book. Maybe it was in your lab manual where they do have the fraction. Ah, go away.
Yeah, the book had one like that,
Yeah.
and they didn't multiply through times 2. They just used that.
Well, so
It's written.
what I say is if I need 13 oxygens and they come in packets of 2, I write 13 halves. Because 13 half O2s is 13 oxygen molecules, right?
Right.
But then what you can do is just double everything to get rid of the half. So if I double everything, then I have 2. 2 times 13 halves is 13, right?
Right.
2 times 4 is 8, and then 2 times 5 is 10.
Oh.
And now, yeah, I just doubled everything. And if you have some 13 over 2 times 2 is 13. So when I doubled everything, I wind up with the right number.
Yeah.
So when we get those weird odd ones, it'd be best to just sit them with halves and then double it at the end.
That's, for me, that's the best way.
Okay.
I didn't know.
Yeah, and you don't want to think like 6 and 1/2. That's like hard, right?
Yeah.
13 halves is much easier than 6 and 1/2.
All right.
Okay. So my to-do list is I'm going to set up a practice multiple choice with at most 15 questions, just in the format of the exam. And I'll post some sample practice free response questions. And I think that's all I will have to finish writing the exam. But I think that's all I have to do. And you guys are going to finish all your homeworks, right?
Yes.
And get in the 90s on them.
Try my best.
I only have
Attempt 3.
So the what was I going to say? I can't remember. Oh, yeah. In terms of asking questions between now and then, I didn't see anything on the discussion boards. I don't know if I'm going to get a notification if someone posts something on the discussion, but I'll continue to look there, and then, or you can email me a question and maybe I'll post it on the discussion board, just so that you can get your questions answered, because we have a long time between now and the exam, and I'm sure you've got other stuff going on right now.
Yeah. Okay.
Well, yeah, and you get notified when we send you emails, right? Because one of my other teachers said that she never gets our notifications, so the emails don't really work to communicate with her.
Oh, I get email notifications, and I'm getting some notifications. I downloaded the app onto my phone, and I've tried. I'm not sure what notifications I'm getting now, but I was getting a ton and it was too many. Not from you guys, but it was because I was enrolled in the other class I was subbing. So every time something happened in that lab, so I tried to simplify it. Oh, and don't forget, there's a pre-lab before 11:30 today. It's due at 11:40, pre-lab quiz, if you're in the Wednesday lab.
And we should be on experiment number 6, correct?
Yeah.
Okay. Thank you.
Yeah, Monday was on experiment number 5.
Perfect. We're good.
Professor,
Yeah.
normally on those pre-labs, they're done online and they say submit. When you hit the submit button, it automatically submits that to you, correct?
Correct. Yeah.
Okay.
Okay. I think I'm gonna. Any more questions?
No.
My question is about the lab. I know this isn't like the lab, but in the pre-lab, since we do them on Canvas, there's not all of those little buttons to like hyperscript and subscript things.
Oh.
So for the last answer for this pre-lab that's due today, the numbers are big and there's no way that I know to make them small. Will it be wrong?
I think it's probably a text. No, if I can understand it, then it should be okay. I'll look. So it's a big number that you're calculating, and then you had to type it out?
No, it's not a big number. It's just, they wanted the empirical formula for something, but I couldn't figure out how to subscript my numbers once I got to the end of it, because it's on Canvas and not Pearson, where they have all those different little tools. So all my numbers are big.
I think Canvas has an option where you can click and you can write a math equation with a bunch of math tools, but you have to like click it and then it opens a bunch of like mathematical tools. But it's like harder to find because it doesn't look like a math thing that will open up a bunch. So if you can find that, I think that has subscript in it.
I think I can figure it. I think it's fine without subscripts, because if it's just formulas, and if there's parentheses where needed, then everything else would be a subscript. I'm okay with that.
Okay, thank you.
Oh, my pleasure. All right, so anything else?
Thank you.
Oh, you're welcome, and thanks for sticking with it. I figure, who knows how long this is going to go on. You might as well learn some chemistry, right? Okay, hang in there, guys. I'll see or hear or whatever from you, a lot of you, at 11:30.
Thank you.
Okay,
Thank you,
bye.
Professor.
Bye.
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 Bye.